Hello, everyone, and welcome to today's webinar, Redefining the Standards of CEA, from Low-Tech to High-Tech Greenhouses, presented by Harnois. I'm Robin Sitberg of Meister Media Worldwide, and I'll be moderating the webinar today. We will have some time for questions at the end of the webinar, so if at any time during the presentation you'd like to ask a question, type it in the question pane at the lower left panel of your screen and click Submit. You can do this at any time during the webinar, and we'll answer questions at the end. Before we begin, I'd like to introduce our speaker, and he is, excuse me, I was just switching our layout there. Let's see, Felix Chaswan is VP of Sales at Harnois Greenhouses, and he's a passionate agronomist. Felix holds a Master of Science degree in Agricultural Sciences from both France and Canada. During his studies, he took a gap year working in Australia across more than 20 organic farms to learn about and visit the country. With more than a decade of dedicated involvement in the greenhouse sector, including 5 years in Southeast Asia representing a European company, Felix brings a wealth of international experience to his role in North America, working now for Harnois Greenhouses, which is a major Canadian greenhouse manufacturer. His comprehensive understanding of the industry, coupled with his scientific expertise, equips him to effectively assist greenhouse growers and provide strategic guidance towards optimal solutions. So now I am pleased to welcome Felix.
Yep. Thank you, Robin, for the introduction. So as you can see here, I just put like some of my background, like more, like for you, like to see what I have done before. And part of my specialization, like horticulture media, and of course, greenhouses. So in the picture, you can see project in Vietnam, part of my study when I was working with R&D for, like with a biochar company, like biomass valorization. So this is what I study at school. And more recently, like project, of course, in North America, but also like in Central America, like the picture you can see, with the leafy greens. This is in Guatemala. And on the top right, it was like a dwarf mango project in Malaysia. So this is what I do. This is what I like. And when I have time, I like also to share my experiences on my blog, Horti Generation, for the one who want to know more, like to have like more details. So, thanks again, Robin, and very glad to be here today. So today we have about 1 hour, so it's about 45 minutes of presentation. So I can speak a lot about greenhouses, and I will try to check like on the timing. But like if you have any question, you can reach me, and the presentation today will be recorded. So anyway, I will stick to the 45 minutes, and you will have time, as Robin said in the beginning, like to ask questions. So, and today the presentation plan is pretty basic, but I mean what we wanted to share with you, it's more our experiences at Harnois Greenhouses, providing from lower tech greenhouse system to very high tech solutions. And I like when we have like concrete cases, and all examples will be like recent project we are working on. Like from Canada to, of course, the States, Mexico, like the picture you see here, it's one of our main tomato and bell pepper growers, a client in Mexico. But I will use like very concrete and recent example to explain the differences between low, mid, and high tech, and like providing more details. So a very brief introduction. So regarding Harnois Greenhouses, I like to define Harnois as one of the main, like I would say, like international North American players. So of course we do greenhouses in Quebec, Canada, where we are. So we have 2 factories in Quebec where we manufacture like the steel structures, also the fabric buildings, the megadome, and now the glass house called Vermax, like the brand. So we have 2 factories, and from Quebec, we share and we deliver our product to like the whole of Canada, the States. All states have like at least like 1 Harnois Greenhouses, and Mexico. So we're pretty big in, like in the highlands in Mexico, Irapuato, Guadalajara. And recently we are also doing project in, like in Guatemala. And we have done project in other parts of the world, like North Africa, China, a few years ago. So this year will be the 60th year of Harnois greenhouses, still a family business. And I will say like a company like very oriented on innovation, expertise, and service. So I worked for another greenhouse manufacturer when I was in Asia. I have seen like difference, and I also like the mentality, how we work. So you will see it through my presentation. So it's also like very brief, why a greenhouse? So first, you know, like I see a greenhouse, for me, a greenhouse is like a tool. It's a tool for the growers, and it has to be, you know, a tool efficient to get, of course, the maximum of light and the free lights. This is one of the main things, especially right now, you know, in Quebec during the winter, you know, like the days are shorter. We have like cloud, and we need like to be able to get as much as light for the crop. And also we can use part of light like, to heat the greenhouse. But the point is we need to have like design greenhouses to be very efficient on natural light, also natural ventilation to create an optimal growing environment for the crops. And, you know, it's also like the main, you know, like the main, one of the, what I want to say, it's like also to mitigate like the effect of extreme weather change, because what we see, especially in the last few years, and I have seen it here in Canada, the last 2 summers were like very rainy, cloudy, but like the greenhouse has to also like be efficient to mitigate the effects of extreme weather change. It can be either drought, extreme rain, extreme wind, extreme snow load. We got about, I will say like about, more than 3 feet of snow last week in Quebec in 4 days. So we have to anticipate it. And in Mexico, it can be the wind. In the States, it can be also very extreme, very warm, humid during the summer in some parts. So the greenhouse, no matter, you know, like the location, it has to be efficient and to protect the crop. And also against the pests and diseases, so the climate and the physical protection, plus like the integration of, for example, beneficial insects. And at the end, it's an efficient tool for the growers. It has to be profitable. We work, it's a business, you know, like it has to work. It, like the growers, they have to make money, and they have to be able to invest, innovate. So the greenhouse is the perfect tool for this. And then the peace of mind, the greenhouse, it's also a protection. When we talk about weather, contamination, market, you know, when you secure a big market and you want predictability and consistency, the greenhouse has to be perfect, and it has to stay like, you know, like strong and sturdy, no matter like the weather. So Harnois greenhouses, so this will show like a bit like the presentation plan, but in short, today I will use like 3 of our main products. You see here, Tunnel Pro Plus, Ovaltech, Luminosa, Vermax, it's like the higher tech gutter connected system. And for each of this type, you know, like a level of technologies, you will see an example. And this at the end, you know, like it's a summary of what I will say today. And no matter, you know, like the level of technology, we have a solution. No matter the growing systems, the budgets, and also the location, we have a solution for the grower. So first, I will start with the first, you know, like the first type of technology. So this is what I call, you know, like a lower tech system, high tunnel or macro tunnel. So more and more, what we see, like with the weather and with, you know, like all the concern regarding the water use, especially in California. So we're talking to Californian growers like recently. The high tunnel are not new. However, what we see more and more, you know, like it's some growers, they cannot grow anymore in open field or to be efficient as before using open field technologies. So we see right now, and especially in Quebec, you know, very large open field growers converting to large tunnel, like you can see here. So big width, gothic shape. I will explain, you know, why we use gothic shape. But at the end, you know, what we see is mostly like for soft fruit, but we see a lot of growers using high tunnel technology to be able to grow and to improve, and also like to be able to use, you know, like the geometry of the greenhouse to be more performant. And when I talk about geometry, in short, what is very important to see, and you will see it for each type of greenhouses today, the air mass volume, it's what we call like the buffer. It's very important because this helps without any technology, without any equipment, just the geometry and the air mass volume, it helped to create a buffer. And what you need to keep in mind is that the hot air with humidity is less dense, so it go up passively. So having, as you will see on the next slide, like a pretty wide and pretty high greenhouse just help physically to keep like a climate uniformity at crop levels. So it's very simple, it's very low tech, but this helped a lot. When I was working in Vietnam, Singapore, we were using very tall greenhouses with other technology, but just the type of greenhouses was helping a lot to have like smoother variations and to have the humidity and the hot air, like more, like on the upper position, as you can see here, and then it's combined with passive ventilation. So this is what you see here, a first example, of a lower tech system. And if I go back to the previous slide, you see we also see like other type of tunnel, smaller mini tunnel, but like the one we designed here, and you will see like on the concrete case on the next slide, we wanted to have like 5 times more air mass volume. So it was one of our focus, the engineering part, the agronomic, like performance was directly correlated, linked to the air mass volume. So let's go to a concrete example. So this is the first project we start last year. At the same time of the year, like the snow was starting to melt and they start like the construction. So we start with the first phase with Pitre. So they have about more than 300 acres of open field cultivation. It's a pretty young company, like about 5-6 years in business, but very innovative. So they wanted to use high tunnel to switch open field cultivation to soilless growing method, drip irrigation, new technology, and using our greenhouse to be much more resilient. So starting 1 month before everyone, using just the greenhouse effect and the volume and the protection. And then by using innovative growing system, innovative also poly to play with the UV for pollination, also the UV for the colors and the, like the colors and the conservation of the raspberries, the strawberries. So this is a concrete example of this trend, lower tech trend. And if you see on the next slide, it started to be big. And for this is just the first phase we have done last year. We work also with supplier with their own expertise like Dubois, providing like very, accurate, precise irrigation system because water is important. And one of the main objectives of this is also to reduce the inputs. So having a very precise irrigation system, fat irrigation system, the point is you will also protect your crop and all, like the fertilizer. When you have like a very strong rain, for example, you will reduce the risk of lixiviation. So this is very effective. And even during a drought, when it's very hot, you can just open, like the poly. We have like wide ventilation up to the ridge, and just protect also the crop because it can be very sensitive to the hot air, to the humidity. So it's flexible. It's not high tech. However, this help. And you will see on the next slide to double the yield, to protect and to reduce significantly like the inputs. And when I say inputs, of course, I talk about the water, but I also talk about chemical application. So it's not chemical free. Of course, like the main goal is to be as, like organic as possible, I will say, but it's pretty hard. It's pretty tough with the berries. So the main idea is to have like a very good growing system for the plant to be able to protect itself, and also like to protect from the fungus attack. So like the UV, when we have, for example, UV open poly, it can help to reduce like the fungus contamination. And then the main idea of the system is also to use like less chemicals, less fertilizer, increase of course the crop density and the yield. And the word predictability, is very important because when you work with supermarket like Walmart, Costco, and others, you need to be able to anticipate your volume, your harvest, your quality. So this is also, when I say peace of mind for the growers, by using a first lower tech system, covering and reducing the risk, you get like more predictability, and this is very important. And climate resilience, of course, it can be like like extreme, and also the wind. Many reasons you will decrease the risk of losing your crops. Because the last 2 years in Quebec, especially like the veggies growers, open fields, they lost about 40% of their yield because of the floods, the water, and the lack of lights. One of the main portals, and we will see it for like the mid and high-tech system, is to be able to be more efficient on the operating side. So by raising the system, by protecting also like the pathway from the rain, and to have like the possibility to combine with automation. But just here in the lower tech system, I can tell you it's about 40% faster to harvest, and they require less labor. So that's a pretty good advantage. And the people, like the best like pickers, they love to work in the tunnel instead of going to the field, and it's tough, and they lose time. Then you reduce the machinery use, because you don't have like to to do soil preparation, but it's not the same. But you don't have to decontaminate the soil, and when you have a soilless system, you have other advantages, and you reduce like the risk of disease by soil-borne disease. So it's also good. And at the end, I have to speed a bit. You increase your agronomic performance. You are much more efficient on the operating side, less input. So we talk about quick return on investment, because the capital investment for a tunnel, it's less than $2 per square feet. So it's pretty, it's a good, it's easier to implement, especially for open field growers, than a bigger greenhouse, a better connected greenhouse. So it has like some good advantages. And then the scalability, it's also, it's easier to, okay, I have one block, I want, like the phase I show you, you want to duplicate the next year, so it works pretty well. So this is a glimpse of lower tech system. And right now I focus, of course, today on softfruit, but we also see it for leafy greens and other crops, citrus, cherry trees. So it's very interesting. Okay, the next slide, it's freestanding greenhouse, but like mid-tech, I will say mid-tech greenhouse system. So here on the pictures, it's a complex of the freestanding greenhouse. We also have like some gutter connected on the top central. But in short, mid-tech greenhouse system, we talk about more, of equipment integration, much more possibility to manage the climate with equipment. We start to talk more about climate control system, greenhouse control. So you will see the differences, but it's this is the next step. We have the high tunnel, and then we go to mid-tech. Still the same regarding the buffer effect. So I like to use this slide to show you, especially when you do like freestanding. So the volume it's lower than a gutter connected. So you have to be able also to manage the hot temperatures in the air. So what we do here is we also have like wider, taller greenhouses, especially for vine crops or cannabis, because you have like a very high photosynthetic activity, a lot of evapotranspiration. So you need to be able to manage it. If not, you will have like issues with fungus and other contamination. So another slide just to quickly show you that we also consider it in our new generation of greenhouses. And climate uniformity is very important. So we want climate uniformity, less variation, temperature, humidity variation at crop level. And when we talk about mid-tech, we start to see equipment. So air circulation, HAF, VAF, irrigation. It can be like a drip irrigation, sprinklers, and irrigation boom, growing benches. Soilless system, of course. But we will start to see more more equipment, like also motorized, roll up on the side, on top. And this type of greenhouses can be used year round, because the lower tunnel I showed you before, especially when we have snow, like Canada's northeast of the state, we need to uncover like the high tunnel. So here it's designed to be much more insulated, and also to be able for the growers to grow year round. So like the difference is we use like only essential equipment. It's just another step, regarding equipment, CEA, but we can use it like to grow many crops. And I will focus more, like I will focus more on the mid-tech greenhouse system, because it's more, like I will say, more efficient. And also, like I will focus more on the high tunnel. So here, it's designed to be much more insulated, and also to be able for the growers to grow year round. So like the difference is we use like only essential equipment. It's just another step, regarding equipment, CEA, but we can use it like to grow many crops. And I will focus more And this example, sometimes, like CEA is more like fruit and vegetable, but I like also to introduce, but to include crops like tree seedlings, because in Canada, we see a lot of, requests for more automation, for mid-tech system for young tree seedlings. So this is an example of a project we are building right now, but it will be finished next month. But here, what you see, it's a gutter connected system. So we have like two main growing area. We use also part of the greenhouse for technical area where we put like technologies like here it's seedlings machine with L-pot. Biotherm is also like a US, a Californian company is also here to work on the hot water heating system on the ground. But I like to use this example because it was like but it was basic, like before when they were using the greenhouse, it was more low tech. And what we see and like the request from the growers is the struggle with labor, the struggle with tree seedling germination loss and young tree loss. So they wanted to have like solutions. So they cannot have like good laborers as before. They have to grow more because in Canada, in Quebec, and here in the Maritimes, and this project is with the government, with the province. There is a deficit of young tree seedlings, so they wanted to use a technology, not like the fully high tech, however, like the mid tech solution, to be able to be much more efficient and to be able to answer the need to grow more. So you see here, we start to use like semi-automated lines, cultivation system optimization, and to have like gains, like to be more productive. So to be more productive, we work with partners, and here we work a lot with Blackmore companies, and they are with air trays. So it's a simple technology, but it looks simple, but it's quite complex, because it has to be scalable, and it has to be easy for forklift and for system to be manipulated inside the greenhouse. So with this system, it's easier to move like the trays because everything is grow in trays. So you need less labor. It's also more efficient to place. And on the agronomic standpoint, it helped to develop like better roots and to decrease the loss of tree seedlings. So it's also a solution helping first like the manipulation, the logistic, the operation efficiency. And on the agronomic standpoint, you have more consistency and better trees. And the main idea is to have like one seedling equal to one tree, better root development, and move the plants to the people, not the people to the plant. So instead of adding like new processes, like the main idea was here like to simplify and to use mid-tech system operation, because we still have like people handling. We have like transplantation lines, but we still use like people to be able to manipulate, like to drive like the lift. But just this help a lot, like the overall, like nursery efficiency. And in this case, they will target to be about 40% more efficient on the labor use. So this will be like a key point, and we are like working very hard on this. So you can see a glimpse of the project. So right now, everything is covered. It was covered like before the winter, of course. And right now, like they will start the operation in March. So this is an example of mid-tech system. So it's passive ventilation, shading screen, thermal, like basic equipment, I would say. But we start to see climate control technologies and a first level of semi-automation. Another project I like is this one is in Guatemala. So we were working, with leafy greens growers. So leafy greens in Guatemala, if you are in the highlands, the climate is great. Like it's I will say it's colder night, not too hot during the day. So you do not need, like a lot of complexity. Like they were growing in the beginning using timber greenhouse. It was working, like this is a way, like they scale up, starting with first block, making mistakes, and then, improving. But what we have done with this client and what we found is that, like in order to get more still consistency and you know, like uniformity on the yield, especially on the lettuce weight. It was very important, you know, to be able to first to use like hydroponic system, and to be able to have like the right climate and the right, you know, like use of the equipment, the volume of the greenhouse, the orientation, without spending too much money. Because here the labor, it's easy to find. They don't need like any heating system. They don't have a lot of pest pressure. So in the mountain, the location is ideal. But they just wanted us to be able to protect the crop, to have like uniformity, and to just, you know, like scale up. Because when you work with big supermarkets, they want every time the same, you know, like 150 grams per head of lettuce. And this is what we have done and what we achieved. So, and every project we are learning more. So this one is a phase 2. We work right now on new phases. And what we do is equipment integration. We do not talk about, you know, like we talk about like mobile gully system, for example, but mid-tech, it's still, we will use people to do the transplant by hand. We will use some conveyors, but we will not have like robot or big system. They do not need it yet, and they have to be like competitive. So in this case, you know, it's passive climate management, like you can see here. We use a VPD. We can use like some parameters, and it's not new, but they want to be also more accurate on the climate management, lower inputs, because we can have like here heat consumption, especially during the cold night, but they want to be as profitable as they can. So it's first, the location is very important. Highlands, you know, also a place where you can grow without cutting a mountain, you know, like using flatlands. So that's very important. Colder nights, good water quality, and automation, but semi-automation to be able to scale and to have the same quality. Then this example is another project in Quebec. When you reach, you know, like a profitability, like I will say point, and you want to like to pass like the next step, this type of mid-tech system are very it's adaptable to be able to implement, to integrate, to plug new technology. So here it's another example. It's a basil production very near where we are in Quebec. So the new block we have done like 2 years ago with a Danish company, VMOs. It's a mobile gully system, and in this case, you know, we have more robot. We have like more transplantation line, more conveyors. So we are able, you know, like when the growers, when the client is ready, also to upgrade the system to be able to plug new technologies and to play. It's still, you know, as you can see here, passive ventilation on the roof. It's not positive pressure. It's mid-tech like HPS, but they're replacing the HPS right now. But the point is, you know, it's still mid-tech, and it works. It's profitable. They can grow. They want to use, you know, like the less labor as possible for some reason, but especially, you know, to have like consistency and to minimize the pest and contamination. And they are ready to transition to high tech. So I like to use this slide to show you like a transition from mid tech to high tech, because then when you have like robot transplantation line and you start to upgrade your climate control system, you are like almost high tech. So this is a good example. And the next slide will also show you in a freestanding, you know, Novaltech. I was there like 2 days ago in very near Philadelphia. So it's a client called Zordi Farm. They use our freestanding greenhouse like the Novaltech to do strawberries. Same system as the high tunnel we have seen before. However, here it's heated first, so it's a grow year round. And what you can see here, like for the people knowing a bit like about like heating systems, so we have the rail. So the rail can be used also, you know, like to diffuse like the hot water. But the rail in this case are used for robot. So it's a mid-tech climate control. Like the climate control system technologies it's not very complex. You know, yeah, you open the roll up, you open the roof ventilation, you just turn off the light. Is basic. However, this company, and they are like developing their own robot. They combine the mid-tech system with higher technology. So here, just a glimpse of like, like the soilless system, the hot water pipe seating, there's the passive ventilation. So it's very mid-tech, nothing crazy about the complexity of the technology. But they use, autonomous robot, their robot, in combination with our mid-tech system to monitor, to pick, to harvest the strawberries. And I have seen it. It was working, like 2 days ago. They were doing tests. But this technology, they want to use like the new, very high-tech technology combined with mid-tech system, and to have like a compatibility between lower capital investment to buy the greenhouse, to buy the technology. So compared to vertical farming and other system, it's the balance, it's quite important, but like the difference is pretty important. And then using those robots to be able to do the work. Right now, the technology, like if you check on if you see on the top right bottom, this robot can pick about 300 strawberry per hour. So it's a good number, but they're working very hard to be quicker and to work to have this technology also affordable for growers, for new people to be able to access to it. And another, like so some more detail, but it's auto grow mode, driven by data. So here it's like, this is why I like to use this technology, because it's as you see here, it's more high tech, like the latest technology are there, like the artificial intelligence. They work with NVIDIA, like on low cost camera. And low cost is important because they do not want to have like technology only 1 or 2 growers in the state or Canada can afford. So the idea is to be able to have scalability and to have this technology, a real technology access with mid-tech greenhouses, and to work, like on the system replicability. So we are just doing like more projects right now. They want to scale up to use more, like greenhouses, to more robots. So it's very exciting, and I like to use this example as a good transition. Other project we are doing in Canada, but still higher tech. And when I say high tech, you start to see also more complexity, more technologies regarding the artificial lighting system. So this one is in Quebec. Still, we work with Horth Americas on the lighting, and it's one of the most productive. It's not a big project, but it's one of the most productive strawberry cultivation year-round in Canada. So they produce very delicious strawberries, hybrids, very good quality, with like the gutter connected technology and the use of LED lighting. We see also more and more dynamic spectrum technologies. This example is another Quebec company called Solum, and this is like based on one of the recent studies they made on another project in Canada, but they have seen significant yield, improvement, growth using dynamic lighting combined with strawberry cultivation. So you have like the source of their document with more explanation and detail on the figures, but this is where, like just on a gutter connected greenhouse, a new system, and even just poly greenhouses, because I'm just talking about poly greenhouses for now. You see the integration of technology and the direct benefit on the climate control, precision, and the direct impact on the climate uniformity and the yield. So I am pretty good on time. The next example, it's, I will say like the very high tech, like one of the most innovative greenhouse system and greenhouse project I will talk about right now. We call it, but our brand is Vermac, so it's a glass house. So this glass house is fully made in North America, so in our like new factories in Canada. And this greenhouse, like the distinction first, it's glass, so it's not poly. And this greenhouse integrates one of the best technologies available on Earth right now. So first, before like introducing the technology, just the greenhouse itself, as you can see, that's a new project, a 20 acres project in Canada, in Quebec. You see here, like the post is very, very high. So we can go like minimum from 21 feet under gutters, as you see here on the right, to 26 feet under gutter And this is the same principle, you know, the same principle of the poly greenhouse is to play with the buffer, the air mass volume, to play also with the shape of the greenhouse, like to be able to reduce like the dripping, to have as much as light as possible, and to have like a good climate uniformity. So if I go back to the glass house, it's the trend, and what we see, but we are seeing it in Mexico for years. In Mexico, it's 50 feet wide, 23 feet high, like more than 6 meters high. So in the VAMAX, we see it even in Nordic climate, and this is the first, you know, like first point, you know, like to be able to grow, and then we integrate like the higher tech equipment. So we do like strata-based climate management, micro management of the growing zone. So this project is for leafy greens. So leafy greens, you know, it's evolutive, especially when you use a mobile GUI system. So while the lettuce grow from, you know, like post germination to like to the final mature stage, like the light level, the climate, everything will adapt. So this is what we are doing here. So it's smart lightning pattern, more efficient misting system, the climate control. We work with the VPD diff directly, you know, like the air exchange, but directly close to the leaf. So I will explain it on the next slide, but it's much more accurate, much more precise than a lower tech or mid tech system. Insect-proof mesh can be removed. Of course, it's more like also semi-closed, positive pressure, or fully sealed. So this type of system are more connected and integrate a higher level of equipment. So when I talk about mobile GUI systems, this is the same as we're doing in Guatemala. So in Guatemala, I did not mention the company, but we work with American Hydroponic. It's a fixed NFT. We're also working on maybe new project with MGS. And when I talk about MGS, it's mobile GUI system. So the GUIs are moving. So this is like, you know, it's pretty simple. They move. So you grow, you transplant from one side and you collect, and you can do like a loop. But then with green automation on this system, we work, it's higher tech. So we work on, of course, on conveyors, transplantation, on many technologies to be able to be as automated as possible, consistent with the right climate uniformity. But the climate uniformity is per growing stage. So you will not receive, like the plant will not receive the same amount of light in the beginning compared to the end. So everything is adaptable to the plant physiology. We see it here. So like the micromanagement of the growing zones, you see the pattern. Every area are like, you know, like customs regarding the climate control standpoint. And also for the lights, 2 lights company are working there. But they work very hard, like on the spectrum selection and also the adaptability of the spectrum according to the plant growth. So this is something we do not see in high tunnel or like in mid-tech greenhouse system. But when we see it, you know, it's becoming more high tech. But the point here, we play on details. So the details, this very precise level of technology and the possibility to be able to play with the data, to create a model. And based on this model to, you know, like to boost it with artificial intelligences and direct, you know, like learning, this is like the next step. So this is why we talk about like very high-tech system, but it's very precise and very precise on where the plant is and where, how the plants, you know, like do the photosynthesis and yet like just the plant activity. So water, it's also like very important. So we'll not go in detail here, but what you need to retain it's more, you know, like we work a lot also like for the water hydroponic system. We have the possibility to recycle the water, to treat the water, and to be able to use also the greenhouse to collect the water to feed like the system, the freshwater tank. So this is very important. Regarding, you know, like the technology, we work with the company Hogendorn on this one. And when I talk about VPDIF, it's the actual leaf temperature measurement. So we use Captor directly, you know, like system to be able to work as close as a leaf to be able to measure like the gas exchange and directly the VPDIF by the VPDIF. In comparison with the classic VPD, like it's not measured in the ambient air, it's directly measured close to the leaf. So you can see like more details here on this slide, but it's more accurate. It better reflects the plant actual needs, limiting unnecessary water loss, and it's more precise. So when we talk about climate uniformity, climate optimization, with this type of technology, you know everything about the plant, and you can also anticipate the plant next chemical actions by use of nutrients, use of photons of light to build your system. And here a glimpse of the project. So it's I say like it's a 10 acres, sorry, 10 acres project. I said 20, but 10 acres project, like the phase 1. So we have 2 main grow zone, like the main conveyors, but technical area, like to be able to exchange with the technical area. So a technical corridor, sorry, and here's the main technical area. Cold storage, post harvest technology. We use also our mega dome to store biomass and many places. So it's a combination of what Harnois also can do, not only the glass house, the poly house, but also the mega dome integration to the wall system. And here's the 3 big tanks you can see here. It's a very innovative climate battery system, coupled with thermopump to be able to, no matter like the season, the time of the year, to have like 3 type of temperature available, like very hot, mild, and cold temperature, to be able to cool or heat the greenhouse according to the growing stage, like the outside climate. And this is directly linked to the Haugen-Doorn technology to be able to anticipate on the next climate and to use as less as possible gas or fossil fuel. So this is why we are talking more about carbon neutral technology, but zero net greenhouses. But this is where like the latest, the finest innovation tomorrow, like in the future, will help the growers to be able to grow, to have like the perfect climate, but also like to be very, very efficient regarding the operation intakes, but like, sorry, like the input intakes. Because when we talk about fertilizer, chemical energy, if you have like good yield and you can control very precisely reduce your inputs, but this is how you are very profitable and you make money. So this new type of glass house, greenhouse system with this patented technology by Harnois, it's very innovative in the way, like we want. And this is in Quebec, like during the winter, and I told you, like we have a lot of snow, it can be very, very cold, but no matter where you are on Earth, this technology is able to heat, to cool, and to anticipate on every crops, like I would say, like leaf exchange to be able to be performant. So this is like showing what we can do, like, and it's very different from the lower tech system, but this is an example of technology integration, semi-automation, new technology like to manage like the energy, and all combined make it like a very innovative system. But not all growers, of course, can access this technology. So this is why, like from low to mid to higher tech, we have like solutions according to the location, the budget, and the size of the project, of course. And this is where we are, like our expertise. We have agronomists, equipment experts, like many specialists. We work with suppliers. So here I named like a few suppliers, but some of the suppliers working a lot here in North America, but we work with many suppliers, many experts. But we have an expertise, and the most important is to understand like where the grower is, where like the people who want to invest is, design the solution, support, and then having like the possibility to upgrade, like in the time. And this is another example of project. So it's a more advanced project we're working on. It's not glass, it's poly greenhouse, but you see we have like hydro accumulation system, mega dome for like the biomass, the wood chip, and everything make it like a unique solution. So I am about to end here. Why Harnois? But like I told you, like the light, how we design the structure first to have like the best of the buffer effect, the best of the light efficiency, the passive, our expertise, the return on investment. So that's very important to discuss with the growers where you want to where you want to be like in 5 years. So based on that, we anticipate the needs and we can give like the best advice to create long-term relation. And it's, you know, it's a fusion of the designs, installations, the service. Project management is key. So we also have like a project management department working very closely with the equipment department, with the growers, of course, and the suppliers. I name, you know, I just name a few. But this is all this expertise and this knowledge transfer. But at the end, helping the growers to be like to be the best and to be able, you know, like to reach, you know, like his goal. And my last slide, in conclusion, like we have like a large choice of greenhouse system, as you have seen. So we are very diverse, not only on the location we work, but also the technology we have, like from high tunnel to glass house, with freestanding gutter connected, and many innovations are coming. So we try also like to stay innovative, to learn the growers. Me, I love this job, I can tell you, because every time I meet the growers, I am learning. And I'm still pretty young, but I am learning a lot. And when I was in Asia, in Singapore, in Vietnam, in Quebec, in Guatemala, Bermuda, every project is different. The market is different. The consumer needs are different. So you need like to innovate. You need to listen, and you need to be able, you know, like to sometimes to contact, to put in relation your contacts, and then to innovate, to be better, and to just to bring you know new technologies, because like we see it, like the climate is changing, the consumer needs are changing, everything is changing. So we need to be able to stay on top and to provide the best. And we support you. So, okay, I have just 2 minutes and 2 minutes late. So thanks a lot for, thanks a lot. And if you have any questions, just let me know. You have my contact here. And now I think, Robin, we have like about 15 minutes to, I will have like 15 minutes to answer the question.
Yes, that is true. And we have a lot of questions. We have a large audience. So we have a lot of questions to get started with. But if you haven't submitted a question, please go ahead and enter your question pane, and we'll get to as many as we can. So the first one is, what are the projected lifetimes for the different A, infrastructure, and B, roofing siding materials used for the different designs? And the reason this person is asking the question is in order to plan for regular maintenance and replacement of those projects.
Okay, like the lifetime more like of the structures and the equipment. Okay. So,
yeah, versus yeah.
But like the main difference between it's more, you know, like the covering part, because like the steel, and especially like the steel we use, like the quality, I would say you can keep it like minimum for 20, 30 years. You need to maintain, of course, like the structures. If you see like any parts, you know, like but you can contact us. But the point is, the structure is very sturdy and it stays like for years, minimum 20, 30 years. I have seen many of Valtex in the States, you know, they are there for 40 years and the steel is still, you know, like in good shape. But the point is for the covering, it depends, of course, your location, because it's directly linked to the UV index. But usually the poly is like 4 or 5 years. So every 4 or 5 years, you need to replace the poly covering, because you can lose on light penetration, you can lose on anti-dripping, on some, you know, like additional treatment. But the glass, you can keep it also like it's very durable. So you can keep it like for 20 years plus. Of course, both for poly and glass, you need to maintain, you need to clean it at least once per year. In some area where you are like near like a open field crops or it's dusty, it's better to clean it every 6 months. But the main difference is poly replacement every 4 or 5 years, and the glass, you need to look at the glass if it's broken, of course, but it's 20 years plus on the structure.
All right. Our next question is about the cost. And maybe you might have to give a range here, or I'm not sure if you can answer it, but how much is the cost with the setup of a high-tech greenhouse? And do you install the greenhouse?
Yeah, but of course, it's a good question. But the main, like from a lower tech greenhouse, I say like about $2 per square feet, even less. Yeah, you know, when depending the size of the project. But the main when we go like to mid high tech and like the glass house, one of the main costs to consider it's of course like the equipment integration. So it's very difficult to reply because it depends what type of crops, where you are, because if you have like a 80 psf of snow, of course the structure will have to be sized according to the wind. In Bermuda we do project, it's 250 miles per hour. 250 kilometers per hour wind speed resistance. So like it's above 100 miles per hour. So it has to be designed accordingly. And for the equipment, I will say for the bigger projects, the equipment are close to be like 2/3 of the total cost. So like to give to you a range, it will be more, like a minimum 3 million per hectares. If I talk hectares, like about 2.5 acres for higher tech greenhouse. And then it depends also like the installation. If you have like qualified workers near and you can take some of your workers to do auto construction, this is much easier. But in the case you cannot, but we will help you. We will support with our team or subcontractor, but we will work and we will be able to provide a turnkey solution. But you have like from $2 per square feet to 3, 4, 5 million per hectares, like for like 2.5 acres. So the price is mostly driven by the equipment and also where you are. So this is very case specific. So the best, if you have a project, contact us and we will be able to help you. First, analyzing like what you need as equipment, as growing system, as installation, and then it will be like you will have like quickly a budget to have an idea if you have to be high, mid, or low tech, and we will guide you.
All right. Okay, I thought that would be a tough question to answer. But, all right, so our next one is, what experience does Harnois have in design, fabrication, and launch of mushroom farms?
Okay, good question. Mushroom, I know we have done like some project with mushroom, but to be very honest, like I will say like on a smaller case, I know mushroom, it depends like the type, because most of the mushroom, it has to be pretty dark. I personally work a lot with morel production in high tunnel, but it was more in China and in France. So you use like freestanding with a very specific percentage of shade, about like 30% black color, a very precise also humidity like point to be able to grow morels. But in Canada and the States, we have done like some mushroom farm, but not a lot. But this is very interesting because I think there is a big potential. And I was doing like insect farming farm like for protein, so to do like animal feed protein. So it's not mushroom, but I have seen like other applications. I have done it a lot in Asia with the black soldier fly. Mushroom is another subject. I am not an expert on mushroom, but of course we are seeing like some smaller project requests and we are active on it. I have one project with mushroom right now. It's for truffles, but it's for the trees. So they do the mycorrhization on the trees and they use the greenhouse to propagate like the mycorrhized trees. So this is a project we are doing right now. However, for a regular mushroom factory, we hear about like the trend, but we do not see, especially like in Canada, a lot of projects right now. But it's moving, like spirulina, cyanobacteria, mushroom, insect farming in greenhouse to create protein, biofuel. It's moving, and we love this project.
Mm-hmm. Okay. One of our viewers says, we have a polytunnel greenhouse with a concrete floor. How do you suggest we keep the temperatures down in the summer?
Okay. But, like it's great. Like I like the heating system on the floor because it's like the heat will go up and it's much more efficient to heat and to have like this directly, like underneath the crop, like for the root activation and to spend more energy. My first answer, of course, I have many questions about the project, but the point will be to use tall greenhouse, shading system. And shading system, what I love, it's we can use many types of shading screen. So it can be, but the percentage of shading can be very precise. So we can use like 50% shade with 30% thermal, so on the same product. So we can like first advise on what type of screen to use, how to use it. Do we use like 1 layer, 2 layers? And then like the main things will be the roof ventilation. Do we have a roof ventilation? Because roof ventilation is a chimney effect because of your humidity and the temperature will go up. This is the best area to be able to, you know, drain out the greenhouse and to be able to manage a good climate, especially during the summer. So the best will be to contact me, but you know, it will be, I will look on what type of greenhouse do you use. Is it possible to add a roof vent if you don't have one? Can we play with the shading screen? And then if you are in a drier area, like maybe Arizona, you know, like the southern state, I love those places because we can play with adiabatic cooling. So we can work with high pressure fogging or cooling, you know, but I like also positive pressure cooling system, but you can raise the humidity in the air and to cool down the greenhouse. So this is very effective only if you're outside, you know, like environment, it's right. Because if it's above like 70%, like when I was in Malaysia, Singapore, Vietnam, it was very, very hard. One of the hardest parts of the world, like to be able to manage the climate. So if it's dry, we have like other tools to be able to cool down the greenhouse. And if you do hydroponic, you can combine with the chiller, just play on the water temperature, because also like the water is where you have, you know, like you can create a microclimate by using a chiller just with your hydroponic system. So in short, I need more details. And then it depends on the location, the crops and many things. But this is what we do every day. So just contact me. You can look at information on my blog, Heritage Generation. So this is what I like to share also. But the best will be to contact me and we will look at it. Yeah.
Okay. Yeah, lots of different tools and options for doing that.
Oh, yeah.
Does Harnois provide the irrigation or fertigation system as well for your greenhouses?
Okay, if we do it.
Mm-hmm. Yeah, I think that's what they mean.
Yeah, of course, but I just, because it's, you know, I have to be quick and I can talk 1-2 more hours. But the point is, you know, like I just put like some suppliers in my presentation, but we work with many suppliers. And for example, Dubois is doing like, is a very good expert and active everywhere in North American irrigation system, growing systems. They are very, very good. And usually we work with the expert. So if you have a project, of course, it depends. If, for example, you are like familiar to work with a Damatex system, a very good company too, what you can do is let us know. We can contact them or put you in direct communication, but we will directly communicate with the expert company to integrate it, the fertigation system, with our greenhouse, because we have to talk each other. So that's very important. But the reply is yes, we do it. We can integrate it. We are integrator of technologies, and our equipment department is able to do like the layout, the synoptic of the solution by speaking to the other expert companies. So this is how it works.
Okay. All right. I think we have time for one more question. And it is, at what point would it make sense to install solar panels on the roofs of a greenhouse? Have you ever had any experience with that?
No, it's very interesting, you know, and me, I work on biomass valorization, so methanization and how to use, you know, like residual heat to combine with the greenhouse, because this is the most efficient, you know, using a data center or solar panel to be able to use part of this to create energy. So we do it. We are currently doing it in the state, but with a mega dome, a fabric building to dry, how do we call it? Like the municipality step, the waste from the cities, you know, like we have like a lot of waste and we need like a mega dome to dry those waste and to be able to purify and then, you know, like store it. Eliminate the germs, and this drying system is combined with an innovative solar panels, like solar concentrator. We see it also for the greenhouse. The main challenge is you need a location where you have enough exposition, and and then it's working. It's you can use it. You just need more. Like from our side to work with an expert company to combine, of course, with the power needs and the equipment needs, especially for cooling or heating systems. This is where we consume the most of the energy and also the lighting. But it's totally possible. And I have seen projects in Australia, like Sundrop, for example. They have like a lot of solar panel they use for the greenhouse and also to do like the desalinization to treat the water to be able to use it in their drip irrigation system. So it's feasible, it's possible, but it's every also like it's very case specific. So based on your location, based on your information, we will advise. And sometimes, like it's maybe most efficient also to use natural gas instead of solar, depending the price you pay. So we have tools to be able to simulate, to model the energy consumption according to the heat source you have, and we will be able to just let you know. Yeah.
All right. Well, thank you. Great information. I know we have a lot of questions we were not able to get to, but we have them on file. We have your email, and either Felix or someone from Harnois will get back to you. So, because they're all important. So I think I have to wrap up the webinar now, and thank you again to Felix. It was a very thorough webinar, and an on-demand version of this webinar will be archived in the next few hours, and you can use the same link that you used to get on today. You'll also get an email reminder tomorrow and with that link again, in case there's parts of it you want to go back and rewatch. So thank you again for your time today, both Felix and our audience, and thank you to Harnois for making the webinar possible. So have a great day.
Yeah, thank you, Robin.